Nice fit. Nice fit. Okay, so we got our 20 millimeters there. So the only thing left is turn this diameter, do the relief in here, relieve this, and thread this. Not bad. Here's where we see if we screwed up. Take this off, rotate it 180 degrees. Tighten it back on. See if we got run out. No run out. Not that I can tell. Nah, we're good. I can take this off and do the other one. Yeah, all the tooling fits on here just beautifully, well within the tolerance of the Chinese wheels I'm putting on it. So everything fits nice. So we're going to leave that alone. We'll do this undercut, this diameter later. So now what I want to do is I want to cut the threads for the retaining nut. So I have to cut up to a shoulder. The shoulder's going to be about 5/8, 625. And the rest is going to be cut down. So I've decided to go with, I can go with it whatever I want, whatever size I want. I want it to be a little smaller than the 20 though. So I'm going to go with 3/4 20. So it's a 3/4 20 thread. So a 20 pitch thread properly formed will have a flat on the top, which will, the V form will be flatted on top at 1/8 the pitch, which is 6 1/4 thousandths. So that means this diameter will be 12 1/2 thousandths less than 3/4, which is 737.5. If I did my calculations right. I'll check that again. Well, maybe 13 and 12. How's that sound? So we'll start with the 13. So, since I've got my tooling all set up and indexed, I'm just gonna, I love this, I'm just gonna pop this off. This is just a beautiful thing. And pop, off it comes. Well, I thought I had enough friction in the 3/8 48 thread that it would take this with it, but it didn't. That's okay. No harm. That's how it works. Very nice. Let's put the other one on. I'm going to screw this one right on here and tighten it up. Nice and snug. Turns true. I'm going to put my same gauge line at 625. Okay, so we've got a nice finish on there. Not that it matters, because I'm going to chew it up with a thread anyway. And now I'm going to cut my relief on both of these so I can... by the way, I did change... I'm getting a much nicer finish now on this. I found that I did need to modify, if I can see this, modify my relief, my back rake, both behind the cutting point in both directions. I increased this relief angle, this rake, as it were. So side rake and back rake both increased, and it's really making cutting a much nicer finish. I don't know if the point's lasting, maybe the point's lasting longer too. Very small radius on there, a few thousandths radius on that tip, if at all. But I'm just doing shallow cuts here, so don't want to sneak up on it, as Stefan Goldwinter recommends. Make your last two cuts about equal depth to have consistent tool loading and flex and cutting depth and all of that, and you'll come out with good dimensions. And this should be right there, 7375. It's exactly what I want. It's exactly what I wanted. Boy, I couldn't have gotten that if I paid for it. And this is, I'm doing this in real time, so you're seeing this. It's right on, dead on. Starting with the major diameter here, which already accounts for the 1/8 pitch flat on the top of the thread. So we're, instead of being at 3/4, we are at 7375. So that's 6 1/4 thousandths less in thread on the major diameter. So to compensate for that 6 1/4 thousandths difference, instead of plunging in the 50 thousandths per side of that triangle, that 50 pitch triangle, we're only going to be going in 43 thousandths. So it works out that the difference is the 6 1/4 thousandths divided by the sine of 60. So it's actually, this is 15% more than the radial depth than the can't see what I'm doing here. Alright. Yeah, anyway. This is not a thread cutting video, but you get the idea how I do this. Do the math, follow the numbers. Okay. Yeah, I'm not as perfect at this as Mr. Goats Winter or Adam Booth or Rob Renz, but we get the job done. It's running true. So now my taper, both axially and radially, are running less than 2/10 on there relative to that, and as well as the run out on this piece. You can see that little, maybe you can see that little scratch that I put in there, but I got the burr off it anyway. So there's the part. This is where it's going to go. It's a nice fit. Now we need to make a washer and a nut. 2. Now, before I take this arbor out of here, I want to just talk a minute about how I index things like this when I make them. I have a number of machined centers and stuff that I can put in my chucks that have come back reliably on center. Now I'll show you how I do that. Okay, so the first thing I'm going to do is I'm going to put a punch mark on here, and I put it right in the center near jaw number 1. So that's my alignment. That's where it's going to go next time it goes in the chuck. And I know a lot of you are saying, and rightly so, well, that's ridiculous, because scroll chucks are notoriously off center and they go all over the place. And yes, the scrolls do not position the jaw exactly in the same place given the position of the scroll. The thread of the scroll actually, deviates radially from a perfect spiral. And even if it didn't, there's other factors, like the entire position of the scroll can shift within the chuck depending on quality of manufacture and all of that. So there's a lot of factors that come into play. However, this is a good chuck, and the scroll fits rather well. It's threaded fairly well. But here's the key. The diameter of this isn't going to change. It is what it is. So these jaws are basically going to come back to virtually the same position on the scroll each time. That's number 1. But the other thing that's interesting, I can take this out of here now. I'm gonna cut this off because it's obviously much longer than I need it to be. I'm just gonna make it as long as the jaws, but we'll do that later. I'll label this as my Deckel tool grinder arbor. Okay, so we're gonna put that aside. So now, when I grind these jaws, everything's going to be gone. All of my references will be lost, or at least one would assume so. However, it's really not the case, because I preload the jaws. When you grind jaws, when you clean up the grind here for when you start to get a little bell mouth on the ends of the jaws, when you regrind the jaws, you have to load them. You have to load them with in going in. You can't put a ring around the outside and load them coming back out, because that's a totally different reference and it's not going to work. So you have to load them going in. So obviously the most convenient thing to do is find a spot behind the jaws where you can put somewhere in the clear where you can put a cylinder or a ring or something to load the jaws. And as long as you're always on that same step back there, I guess you'd be in good shape. But not all jaws have a step back there that you can get a ring on. However, this this grabs the jaws and still leaves their actual contact face. Let's see if I can do this. Okay, so you see how that fits on there, and it grabs the jaws on this angle adjacent to the actual jaw face. So when I crank it in, it centers on these two angles on the side, and the jaws are always in the same place until I grind them back so far that obviously I'm beyond this, at which point I really should just go out and buy another chuck. So when I tighten this down, it always comes to the same place in the scroll, and it's always being cut on the same diameter. Everything's in the same position. So even if I took a few thousandths, you know, maybe 1.5 off of here and 1 off of here and 1.25 off of there, when I'm all done, I'm basically back at the same, virtually the same center as I was before, and things move very, very little. So I've reground this chuck probably 3 times in all the years I've had it, and all of my centers and all of my jigs that I have made to fit this chuck are still on center within well under 0.5 thousandths, maybe 3 or 4 tenths. I know that sounds ridiculous, but that's, you know, maybe I stepped in poop outside or something and I just got lucky, but there you go. Works for me. So, all right. And I have made a loading template like this for all of my chucks that when I have to grind them. My next chuck's going to have replaceable soft jaws, so it won't matter so much. Okay, so once again, I find myself having to apologize for my inept production staff. We ran out of memory on the card, on the camera, before you got to see me thread these. And like I said, we don't want to make this a thread cutting video. So what I'm going to do is we're going to cut a similar, really nice fit. We're going to cut a similar thread. So obviously in both of these cases we have a non-standard thread. We have a very large diameter with a fine thread, or a much finer thread than is normally found on that diameter. We have a 3/8 48 and a 3/4 20. 3/4 20 is not that weird, but the 3/8 48 is pretty fine thread for that size. The kind of thread you'd find on instrumentation and adjustments and things like that. So what I'm going to do, since you missed the cutting of this thread, how I cut how I cut threads like this and virtually guarantee that they will fit. They will work out, and they will be repeatable, or at least measurable, by somebody who follows and tries to do the same thing. I mean, these are interchangeable, and so they should be. So what if I did not have, what if I needed, of course if I drop it and lose it, I might have to make another one. Well, what if I needed to make another one of these and I did not have this part to fit it on? Just somebody just telling me what it is. How do I go about making this so I can be reasonably assured it's going to fit well? So that's what I'm going to go over. I'm going to direct you to another video. I'm going to make another video. I know I said I was not going to try to repeat what others have done, but I think I can get a little different twist on this. So I'm going to direct your attention to the whiteboard, where I will be going over all of the details of how to measure both your diameters and your depth of cuts so that you can cut threads on non-standard diameters and be reasonably assured that everything will go together nicely and be repeatable and follow all the standards. Should be fun. Please look forward to that. In the meantime, thank you very much for watching this lengthy video, and we'll let you know how everything spins up on the cutter grinder shortly. We got a few more things to move around the shop and make some room to play with that, and we'll look forward to our next video. So bye for now. Stay well.